All right, so the first thing we need to do, all right, is make sure you get all the supplies here. Then, all right, we need to insert the 6-inch red hook of the wire into the breadboard strip marked plus. So we're going to take this guy right here, go ahead and put it in the plus sign. All right, and then we're going to take this guy, insert it in the negative area here. We got to clip these guys in. Oop, let me redo this one. Okay, now we want to, with our little alligator clips here, clip that guy on, clip that guy on. All right. Okay, and now it says to turn the current dial fully clockwise so that the power supply will deliver a constant voltage. So let's turn it on. So make sure the voltage here is at 9 volts. Turn the current all the way up, okay? And we want a voltage of 9 volts. Oop. Get as close as you can to it. So let's go ahead and turn this guy off now. All right. So now we need to construct a simple circuit displayed using a 330 ohm resistor, a diode, and a switch in the open, or essentially off position. All right. So let's basically you need to interpret this guy and go ahead and create it. So to do that, okay, take your 330 ohm resistor here, place it in the plus sign, have it come over, push them in the slots real good so you know they're in there. Okay. Now, make sure it goes in the right spot. We need to put the switch right next to it and push it in good there. Okay. And now, we need to add our diode. And remember, a diode has a plus and minus side. So, you can do it like that. And here, I'm kind of lazy, so turn this guy back on to 9 volts. And you have a current. Okay? So let me kind of zoom in here. So you see, the current comes in here where it's red. It comes through the resistor into the switch. Let me move the resistor a little bit here. It goes into the switch, up through here, into the light bulb, over here, and out this black wire here. So we have a complete circular simple current here. All right? Now, we need to use our multimeter. So we need to find the voltage across the power supply. To do this, turn your multimeter on to, okay, 20 here. Because we have it at 9 volts, it's above 2, so we got to go on 20. So what we can do then is just take our multimeter here, put them on here, and you can see we got a value of 9, okay? Do it one more time. .2. Okay. So go ahead and record that. And now we need the voltage across the resistor with the switch open or off, essentially. So we'll once again take our, put it there, and that's 0. And now we need to do it across the diode or our LED light. And that's 0 as well. Okay, and now we need to find the voltage across the resistor with the switch closed, or in other words, the switch is on. So, let's count over here. It's kind of hard with one person, but we can do it. I can do it, I think. Let's see here. And the voltage is 7.39. And now we need to do it across the diode here, with once again the switch on. And 1.84. Now, according to Kirchhoff's law, these two should add up to our total voltage of 9. Okay, so how does the voltage across the resistors change during the first few seconds? In this case, if you notice, it increased slightly. Okay. And now we need, for number 6 here, we need to find the current for the power supply display here. And to do that, you can use your multimeter. However, I would rather you guys use a little caution because I've blown a lot of fuses on these things. So just use, all right, a amps or current of 0.02 amps is what the multimeter will give you. Or we got 20 milliamps. Okay. And then the resistance of the resistor. Okay, so we need to find now the resistance of our resistor here. What is the resistance? It gave it to you, but let's calculate it. So we just need Ohm's law. Voltage is equal to current times resistance. And it says here use the resistor in the previous step for the current, okay, which was 7.39. Okay, so substitute our values in. We have voltage is equal to 7.39. Okay, and we have a current 0.02. Okay, and we can solve for ohms here. So and we get 369. So that is the resistance, okay, or 370. That is the resistance of our resistor, okay. And as we know, it's actually 330. So you should be somewhere in the ballpark with these numbers. Okay, a couple things I want to go over. If your light is not lighting up, okay, check to make sure everything's pressed in, okay. Also, check to make sure everything's in the right slots, in the right holes, okay. A lot of people don't realize it, but they're one off sometimes. All right, check to make sure your light is not in incorrectly, because if it's going the wrong way, it's a diode, it needs to be inserted correctly. So if I reverse it here, notice it doesn't work. All right, so there we go. All right, and finally, the last thing you guys should worry about, when you're doing, if you're having trouble getting any current readings on your multimeter, it means you have a blown fuse and you need to replace the fuse. And I have more if you need some. Okay, so those things, okay, double check all of those aspects. And if you have a blown light too, by the way, you may have to replace your light because sometimes they short out. Okay, so after you've tried all those and you've troubleshooted all those options, you should get a nice current with a glowing light here.